Alright, quiet please. Okay, horizontal asymptotes. Before I even do that, let me just start with this. How many, let's say it out loud, I'll give everyone a chance to think about it. How many vertical asymptotes could there possibly be on the graph? Vertical asymptotes could there possibly be on the graph? Yeah, go for it. Infinite is correct. So you guys know what tangent looks like? Graph tangent. I don't know if you remember it, but it goes like that. There's a vertical asymptote. Like that. There's a vertical asymptote. Like forever. So you can have as many vertical asymptotes as infinite. You could have infinite amount. Same thing. Don't say it out loud. What about horizontal asymptotes? How many could I have? Don't say it out loud. Two? Where? Where are the two possible on the graph? But you don't know what the graph looks like. You guys are pretending there's a graph. Okay. So, horizontal asymptotes happen at extreme x values. So they happen when x is negative infinity. As I go all the way this way, if the graph levels off, you would have a horizontal asymptote. So there's one possible at this side. As x goes to negative infinity, we want to know the values that are happening as that happens. You might have heard it called end behavior. I don't know if that's a term you've heard. But like way on this side is one possible horizontal asymptote. And way on this side is the other. And what happens in the middle doesn't make a bit of difference. For example, if that's a horizontal asymptote as x goes to infinity, the graph could look like this. Where I blasted through, so think about vertical asymptotes. Can the graph touch a vertical asymptote? No. Can the graph touch a horizontal asymptote? Yes. So this doesn't matter because x isn't infinity or negative. All I care about is what happens way over here and what happens way over here. If it is converging on a certain y value, that's a horizontal asymptote. So horizontal asymptotes are limits at positive and negative infinity. So you might have 0, you might have 1, you might have 2. You can't have more than that because there's only a left side and a right side. There's only two sides. So if I go back to if you have a graph, it's one thing, but usually you just have an equation and you're asked to find like the limit as x goes to negative infinity or infinity, or just tell me where there's horizontal asymptotes. There's only an asymptote if there's a fraction. And then we look at, in a fraction, three things are possible. The top might be bigger or grow faster, the bottom might grow faster, or they might be tiny. So we look at each one of those cases and say, like, what happens? So if the bottom grows faster, or if you're really fancy, the denominator. So this is sort of what we did yesterday. If I have like 1 over 100, what's that? That's 0.01. Well, if I make the bottom get bigger, now it's 0.001. If I make the bottom get bigger, now it's 0.0001. So as the bottom gets bigger and the top is really tiny, what is this going to approach? It's going to approach 0. These values are getting closer and closer to 0. They'll never be 0, but they'll get closer and closer and closer. So when the bottom grows faster that means there's a horizontal asymptote. So there's like terminology kind of gets in the way. So this means the limit as x goes to plus or minus infinity, it is 0. Or there's a horizontal asymptote at y equals 0. Those are saying the same thing. A common thing that people get wrong is they'll tell me there's a horizontal asymptote at 0. If you just say 0, it's not a line. I need like y equals whatever to indicate that you know it's a line, not just like a point. So if the bottom grows faster, we tend towards 0. If the numerator and denominator grow equally fast, you'll get two numbers that are getting bigger at the exact same speed. So you can have a number divided by itself, and that's 1. So horizontal asymptote at y equals 1. If the top numerator grows faster, that would be the opposite of this. So like 100 over 1, 1,000 over 1, 10,000 over 1. Is that getting closer and closer to a value, a certain value that's not going to touch, or is it just getting bigger forever? That's just getting bigger forever. That's not like zeroing in on a target. That is just going up, like y equals x squared. This part of it. That just goes up forever. So there's not a horizontal asymptote there. So if the top grows faster, there is no horizontal asymptote. So let's start doing some. I think it makes more sense than it probably seems like right now. This chart we've kind of already talked about. In general, the bigger the power is, the faster it grows. So like if I compare, let's do a tournament. X squared, x to the third, who gets bigger faster? X to the 10th, 2 to the x. Remember, x is going towards infinity. So it's like 2 to the infinity, so that's the bigger power, because infinity is pretty huge. So this is 2 to the x. E to the x versus 4 to the x. Why? They're both the same power. Because 4 is larger. So remember, E is like 2.718. They're the same power, so then it just becomes like, what's the bigger base? 4 is bigger than E. We're eliminating him from the term. X to the third versus 2 to the x. 2 to the x, and 4 to the x got to buy. 2 to the x, 4 to the x. 4 to the x is our champion. Alright, we don't need to fill all that out. That's good. Alright, so let's look at number 4. Find the horizontal asymptotes of each function. So when I'm asked to find a horizontal asymptote, I need to check x approaches infinity and x approaches negative infinity. Because there's two possibilities. There might be an asymptote way out in left-hand negative land. There might be an asymptote way over there in right-hand positive land. In number 4, where's the higher power? Oh, there's the bottom. Okay.
Those do not sound alike.
Well, it's just like a mouth. So the bigger one is on top. All you care about is the term with the highest power in it on the top and the term with the highest power in it on the bottom. So the 4 and the -5 are literally meaningless. When you're at like infinity squared and you add 4, it like doesn't matter. It's like putting another grain of sand on a giant beach. It doesn't do anything. So the bigger power is on top. So that means there's no horizontal asymptote. That means we're either going up forever or down forever. It's not leveling off. So it's either going to go up forever or down forever. We're going to check both. As x goes to negative infinity. So first of all, my answer is going to be as x goes to negative infinity. Where's the bigger power? I already asked that. Where's the bigger power is on top? So you're going to plug in negative infinity. I take negative infinity and square it, it becomes positive, right? If I plug in negative infinity there, it's negative. I end up with a positive divided by a negative. My answer is either going to be positive or negative infinity. I'm just trying to figure out which one. So because this ends up as a positive divided by a negative, that would be negative infinity. And that is not a horizontal asymptote. That just means the graph goes like down. I need to check the other side also. As x goes to infinity. What? So it's going to be, my answer is going to be either positive or negative infinity. I just have to figure out which one. So I plug a positive into the top, it's still positive. If I plug a positive into the bottom, it's still positive. So this is infinity, and there are no horizontal asymptotes. So that means on the right-hand side, it goes up forever, and on the left-hand side, it goes down. I don't know or care what happens in between. I'm just looking at, like, way over here. Okay, it's going up forever. Way over here. Okay, it's going down. Question number 4. Alright, 5. This is a tie. So I don't care about the +4 or the -5 because I only look at the biggest power in each spot, beneath the top and the bottom. These x's cancel, right? And I just get like 1/3. So there's no x in there anymore. I cancel it out. So as x goes, x can do whatever the hell it wants. What's 1/3? 1/3. Like it doesn't change. So there's a horizontal asymptote at y equals 1/3. So that's the rule I set up there. Like if they're tied, if the highest power is tied, you take the coefficients. And the reason you're doing that is because the x's will go away. You just take like what's left. Is that part okay? Number 6. And then in this one, why didn't I have to check negative infinity and infinity? I should have talked about it. Supposed to check both sides. Why didn't I? There's no x. So it's just 1/3. Like I can go negative 10 million, I can go 10 million, whatever. There's just one. There's just 1/3. So it's 1/3. Alright, as I look at number 6, where's the higher power? Why did they write +4, -5 literally in every row? When the higher power is on. It was a rhetorical question. Higher power's on the bottom. So I'm going to check, I'm going to say there's a horizontal asymptote at y equals 0. And I don't really have to worry about the signs here either, because you can approach 0 from positive or negative, it's still going to be 0. Like if I plug in a positive number here, I'll approach 0 from the positive direction. If I plug in a negative, I'll approach 0 from the negative direction, but I'm going to get 0 either way. Higher power on the bottom, horizontal asymptote, y equals 0. Every time. I hate saying that. Because then there's going to be like this one like weird problem. I'll say, I can't think of a situation where it doesn't happen. But I'm just scared to say always, because that'd be like block you, like if something changes, you're like, you said. Yeah, seriously. Okay, 7, 8, 9. The deal is you have to simplify before you compare the powers. But when you plug back in, you plug into the unsimplified. So for example, if I said where's the highest power there, it's tempting to say the bottom, because like that's kind of squared and that doesn't look like it has a squared. But if I actually went through and factored it out, or like multiplied it out, what will the highest power be on top? X squared. And I don't care about the minus 2x plus 5x minus 10. It doesn't matter. When you're dealing with that big numbers, minus 10 is not going to change anything. On the bottom, my highest term, the term with the highest power would be 16x squared. And then what happens to the x's? They cancel, so I no longer care if x is positive infinity, negative infinity, whatever, it doesn't matter. There's a horizontal asymptote at y equals 1/3. 116. Yeah. Why did we? Why didn't we check for both sides? If it's zero, you don't have to. Like it's coming at zero from above or below, but it's still coming at zero. Yeah. Yeah. I think so. 8. Simplify first. You only simplify the biggest term. What is the square root of 4x squared? 2x. So we have to check this one too. So Carter, I don't know how you want to phrase this rule. So that's 2x over 3x. But these don't like straight up cancel because this isn't really 2x. It's just like pretending to be 2x. This allows me to compare the highest powers. So the highest power is a tie. But in this case, I can't just take the 2/3 automatically. I do have to check the. So anytime it's not 0, I do have to check. So as x goes to negative infinity, first it's going to be either a positive or a negative 2/3. As I go, I'm just like that's blank. There's no sign there. If I put a positive number in, does the top come out positive or negative? Square it, multiply by 4, square root it is positive, right? At the bottom, that's positive. So as x goes to infinity, positive infinity, I get a horizontal asymptote at y equals 2/3. This is when x goes to infinity. But if I check the other one, the square root changes things. So if I plug a negative infinity in, what's the sign on the top? It's still going to be positive, isn't it? The negative gigantic number, whatever you want it to be, square it, now it's positive. Multiply by 4, still positive. Square root it, still positive. And then on the bottom, it's going to be positive. So we do have y equals 2/3 there. Also, as x approaches negative. So there's just one horizontal asymptote, but I wanted to check both to make sure. Oh, yeah. Yeah, that's the point I was trying to make. So if I plug the negative into the bottom, what do I get? I get a negative. So I'm gonna have when I plug in negative infinity, I get a positive on top and a negative on the bottom. That's like literally the point I was trying to make, and then I just forgot.
I think it's so silly because like all around the room, everybody in sync goes.
That's good. It means you understood it, even if I don't. Questions on 8? I kind of screwed up explaining that. Are we back? Number 9. Really similar, but before I get to 9, let me make sure you. This is a very common mistake I'll see. What is that? The square root of 9x to the 16. I'll even give you multiple choice. A or B? It's A. It's very tempting to see the power and then square root the power also. But if you did 3x to the 4th times 3x to the 4th, what do you do with those exponents? You add them, and I don't end up with the 16. Where if I do it here and add those powers, now I do get 9x to the 16. The number gets square rooted, and the power gets divided by, like, there's an imaginary 2 out there that it gets divided. It doesn't matter in this one because it's 4. Whether you square root it or divide by 2, it's the same thing. But it can matter in others. So that, if I simplify that term, it's 2x squared. On the bottom, it's 3x squared. So I'm going to have some sort of 2/3. But I need to consider positive, negative aspects of it. So if I plug in a positive huge number raised to the 4th power, it's still positive. Multiply by 4, it's still positive. Square root it, it's still positive. The bottom is positive. So I do have y equals 2/3, and that's as x goes to positive infinity. You don't really have to write this part, I'm just trying to like show you where it came from. But if I plug in a negative infinity, see if I get it right this time. Will the top be positive or negative if I plug in negative infinity? positive. Will the bottom be positive or negative? It will also be positive. So this is the case in both. So it's just 1 at y equals 2/3. Questions there? Alright, for the E1s or anyone with a power, remember that like what is anything to the 0 power? 1. So as x goes to infinity, that's like -4e to the 1 over infinity, which basically means the higher power is on the bottom. So the higher power is on the bottom, 1 over infinity actually becomes a 0. So now it's -4 times e to the 0. E to the 0 is 1. -4 times 1 is -4. And 11 is the same. It looks like it's different with the power. It's not the same answer, but the same thing with the power. It looks like it's different, but isn't. No, it's not. I'm sorry. I thought it was actually a good one. So alright, so we're going to go limit as x approaches infinity. I would rewrite it like that. Because how do you get rid of negative exponents? Flip it to the bottom. Now that we've done that, where's the higher power? On the bottom, so what's the answer? 0. The higher power is at the bottom, it's 0. Questions on any of those like warm-up ones or notes ones, whatever? Yeah. These ones? Oh, there's a note. Let's go. Yeah, let's do those. Okay. What's the biggest? So I'm doing number 12. What's the biggest value sine can ever be? 1. Smallest value sine can ever be? -1. So on the top, I basically have a number that's between 1 and -1. So when I plug this in, sine of -10 million pi, I don't know, but it's either 1, -1, or something in between. On the bottom, I have a giant number. I have infinity. So this is 1 divided by a gigantic number, which comes out to 0. I don't know how to notate this, but it's like you have something between -1 and 1 over, some huge number, and that's going to approach 0. That's not the way to notate it, but I don't really know. Yeah, so that's the problem. Yeah. Alright, 13. So plug in some giant number for x. Cosine of 1 over x. Bigger powers on the bottom, so what does 1 over x turn into as x goes to infinity? It turns into 0. So now this says -3 times cosine of 0. We can do that. What's the cosine of 0? What's the x value at 0 degrees? It's 1. So -3 times 1. Now it's -3. What's up? Yeah, it's just not like technically right. There's no real way to notate it. I was just trying to make up something that like showed it, but it's okay. Thanks for focusing. Sine of x. So sine of x, what's the sine of 0 degrees? What's the y value at 0? 0. It goes like this. Forever. Does that ever level off and zero in on a certain y value? It does not. The limit here does not exist. And the reason is because it's oscillating. That just means like going back and forth. Let's go back and forth between 1 and -1. So, so a horizontal asymptote, it has to be like something that the graph is getting closer and closer to, but it'll never touch it. So, or like from this side, it's getting closer and closer to that, but never touches it. The sine of x, just goes like this. It's not getting closer and closer. So if you want to tell me some answer, like if infinity's here, the answer is 1. When I can't say infinity's there. Maybe it's there. Now it's zero. Maybe it's there. Well, now it's negative one. There's no certain fixed spot I can say that's what's happening. There's nothing it's zooming in on. It's just going back and forth. So, yeah.
Can you have a, or can you have a
You can if the oscillation's getting like smaller and smaller as you go. So I put one. That I mean, sine of x doesn't do this, but if you had like this, that could be a horizontal asymptote away. Uh, 15. So cosine of x. So I'm basically asking you to take cosine of infinity, but I don't know where infinity is on a cosine graph. Cosine just goes like this. So I can't say what the value of that is when x is infinity because depending on where the side of infinity is, it's different. So this is also d n e because it's oscillating.
Wait, is it always does not exist in no fraction?
Are there questions? So let's say you guys start trying it. Let's see how they go. You guys like help? Let me know. I can go through more stuff up here. I can go over to your desk. Whatever. So I'm holding you responsible for all of the test prep in this one. So you're doing the whole deal.